Okay, welcome to the next installment, Calculus Continued. We've got it's time for tangents and normals, and so what we know so far, what we hopefully know so far, is that we're talking about change, aren't we? The mathematics of change, and we're looking at measuring change. And how do we measure change on a constantly changing curve? How do we measure change from one point to the next? So what we've discovered, what we've talked about, is that the rate of change, the measure of change at any particular point, is equal to the gradient of the tangent at that point. So our attention is focused on this fella here and what his gradient is, because if we can find his gradient out, then we know the rate of change right there at that point. Massive information for us, huge implications. So, all right, so we go from there to say, right, oh, that's great, and we've worked out that through a process of finding the gradient of the line that joins a secant and bringing that secant back so that it's almost just right on top of the orange dot here, and using that limit as h tends to 0. We did all that stuff, didn't we? And we came up with these gradient functions, and then we spotted that there was a little rule going on, and that if we had y equals ax to the power of n, then y dash was equal to an x to the n minus 1, and it went from there. We've done some practice on that, our indices are getting better, etc., etc. A little summary of where we're up to. Okay, right, next step is to find the equation of this tangent. Find the equation of it, right? So that shouldn't be too much of a problem, should it? We know how to find the gradient of it now. We use differentiation. Then we just use what do we use? We use that old y minus y1 equals mx minus x1, don't we? So this is the equation of a line when you know what the gradient is. Right, there's a gradient there, and we're going to get the gradient using differentiation, which will be very exciting. And x1, y1, this is the point here. This is a little orange dot. That's the point x1, y1. We have to be given that. So we can either be given both x and y, or we have to work x out from y. That won't be a problem for us. But we're gonna use this here. So let's get to work. This is the cubic x cubed plus 2x squared minus 1. So its derivative is what? 3x squared plus 4x. Do you agree? Okay, now what we see here, we don't see anything at all. We just see a dot moving along the cubic at the moment. But if I check that tangent box, then there's the tangent there. Okay, as it swings around, and that the gradient of that tangent, that tells us what the rate of change at that point is. What the rate of change at that point. Right. So that's good. What's the normal though? That's the normal there. So that is the perpendicular at the point of contact with the tangent. So it's the perpendicular to the tangent. Normal and tangent are perpendicular to each other. Have I said that enough now? So how are we going to find the gradient? So the gradient of the normal, and hence the equation of the normal. Well, the relationship between gradient lines and did I say gradient lines? The relationship between perpendicular lines are that their gradients are the negative reciprocals of each other. They product to minus 1. Let's just get all that down. So perpendicular lines, M1, if M1 is perpendicular to M2, then this is a if M1 is perpendicular to M2. Does that make sense? This gradient M1 is perpendicular. I shouldn't say that really. That doesn't really make sense. If I'll just put it this way: if two lines are perpendicular, their gradients product to minus 1. Alright, so therefore what that means is that M1 by M2, they're the two gradients, will equal minus 1, or often visually it's easier to look at them as they are the negative reciprocals. Alright, so we're going to do some examples now. We're going to use this information here about what a normal is. Right, there's my tangent there. My normal goes through here, makes a right angle. So this is tangent here, tangent, and this guy here This one here is, he's a normal. Okay, makes a right angle at the point of contact with the curve. Okay, so let's have a look at an example or two. We're coming from page 205, so we're going to write an equation for each line. Write an equation for each. Okay, so 1, we're going to go for the tangent. So we're looking at the tangent here, tangent line to the curve f of x equals x squared plus 1 at the point 1, 2. Okay, so we had a look at something like this in class today, didn't we, where we went, okay, the tangent line of the curve. Well, I need to find the derivative, and now this is 2x. The derivative is 2x. So that means at this point 1, 2. So this is x squared plus 1. If you want to have a little look at it, just if that might help, you know, this is y equals x squared. That's got a horizontal translation, vertical translation, sorry, of 1. Goes up like that. The point 1, 2 is here somewhere, and its gradient, you know, sorry, its tangent does a bit of that, doesn't it? So the tangent line of the curve at 1, 2, so 2x is the gradient function. Now that's equal to 2 at x equals 1. So the gradient of this line is 2. And it goes through 1, 2. Right, it goes through 1, 2. So now we just need to use y minus y1 equals mx minus x1, and we've got the equation of this tangent. So therefore, y minus 2, we have the y coordinate there, equals m. So m is 2, the gradient, x minus 1. That's the equation of this line here. Therefore, y minus 2 is equal to 2x minus 2, and therefore we make y the subject. It's probably the neatest way of doing it. It says y equals 2x. In fact, that should go through the origin if I'd drawn that correctly. Okay, next question. So what we're doing is write an equation for each. 1, the tangent at that point. 2, the normal to the curve f of x equals 2 square root x when x equals 9. Not giving us the y coordinate this time, being a bit tight. And this 2 root x is just one of these kind of curvy things. So we could just you know what 2 root x looks like, don't you? Something like this. All right, when x equals 9, so out here somewhere when x is 9, what's the equation? Not of the tangent this time, not of the tangent, not of that, but of that, the normal. We want that one there. We want the equation of that. So what's the point? Firstly, what's this point here? When x is 9, y is equal to, put this in here, 2 root 9, which is 6. Righto, so we now know that that is the point 9, 6. What's the gradient of this line? Well, we firstly need the gradient of the tangent to find the gradient of the normal. So we're going to find the gradient of the tangent. We'll find that out by deriving the function f dash x. Well, this is 2x to the half, isn't it? So perhaps I don't need the dash there just yet because I'm not ready for it. So f of x equals, I'm going to write it in, as I was saying today, clear coefficient, base and power, 2x to the half. Now I can write f dash x. It's a half times 2, which is 1. So a half times 2, 1, so it's x, and then we subtract 1 from the power, so it's x to the minus a half, which might be easier to work with as 1 over square root of x. Now when we put x equals 9 in there, we get 1 over 3 at the point 96. So my gradient is 1/3 here. My gradient is 1/3. That's 1/3 for the tangent, but we don't want the tangent, we want the normal, so the negative reciprocal. So therefore, gradient of normal is equal to the negative reciprocal of this, so -3. So therefore, equation of normal looks like this: y minus y1, 6, equals -3 x minus x1, which is 9. So therefore, we just tidy this up. Y minus 6 equals minus 3x plus 27. Therefore, y is equal to minus 3x. We add the 6 there, that's a plus 27, so that's plus 33. Minus 3x plus 33 for the equation of that normal. Okay, just pause there for a moment. Right, we'll look at one more example, and this one is we're trying to find the tangent. We want the equation of the line. Remember, we're doing an equation for each. So the equation of the line, equation of the tangent to this function here that is parallel to the tangent at 421. So what's going on here? Okay, so parallel to the tangent at 4. Okay, well, I need to find out about this tangent here, don't I? So let's go in to find. Oh wait, as soon as we start talking tangents, parallel, we're talking gradients. Gradient function. Come on, 3x squared minus 6x. That's gone now. That's down to 1 minus 13. That's my gradient function. And at 4, what's that equal to? Right, so we want f dash 4, don't we? Because that's my point here. So f dash 4 is equal to 3 by 4 squared is 16 minus 6 by 4 minus 13. What's this getting me? 3 by 16 is 48. Take away 24, take away 13. So we're left with 24 minus 13. That's 11, isn't it? So my gradient here, at this point here, is 11. So I want to know where else the gradient to this curve is 11. A bit like the question we did today. So I'm going to go back into this gradient function here and find out where 3x squared minus 6x minus 13. Remember, that delivers for me the gradient at any point. I know the gradient is 11. I want to know where the gradient is 11. So I'm going to solve this equation. So therefore, 3x squared minus 6x minus 24. If you take that off, is that right? Equals 0. Divide through by 3x squared minus 2x minus 8 equals 0. Alright, now what are we going to do? X minus 4, x plus 2 equals 0. X, is that right? Yep. So therefore, x is equal to 4, or x is equal to minus 2. Now here's my 4 here. I've got my 4. So what this is saying, on this cubic, there's 2 spots at which the gradient is 11. There's 2 spots where the gradient is 11. One's here at 421. The other one is when x is equal to minus 2. Okay, so at x equals minus 2, this is now the tangent. This is the tangent I want at minus 2. So at x equals minus 2, all right, when x equals minus 2, y is equal to, got to go in here now, minus 2 is cubed is minus 8, minus 3 times minus 2 squared is 4, so minus 3, that's minus 12, minus 13 by minus 2, that's plus 26, plus 15. All right, that's equal to, here's my working out, minus 20, plus 26 now it's 6, and 15 is 21. So I reckon at minus 2, 21, so therefore at minus 2, 21, gradient of curve is 11. So it's parallel to this tangent. Alright, so I just now want the equation of the tangent at minus 2, 21. It's got gradient 11. So therefore, equation is y minus 21 equals m x minus x1 x plus 2. Therefore, y minus 21 equals 11x plus 22. And therefore, y is equal to 11x, 22 and 21, I reckon, is 43. So y equals 11x plus 43 is the equation of that line. Okay, let's do some exercise 7G in class tomorrow. See you then.